We all know that, as process equipment, robotics moves parts and goods in a bidirectional manner. Then comes a suitable means of achieving this. That is to develop a means of achieving this with cost in mind.
So that is to develop a means of achieving these using one single electric motor. So with cost in mind, then we will need to devise a means of achieving how items can be moved both ways just by using one single electric motor instead of using two motors for the same purpose. Because using two motors will result in more spend cash during the initial setup. And also, not only during the initial setup cost that we are looking at, but also on the running cost. Because the amount of money that will be needed to keep the two motor running will be twice the amount needed for just one motor. Hence the reason.
Using one motor instead of two will ensure that the space within is well utilized. Less wire terminations will be required. And when you factor all these, the setup cost will be almost half and there will be space available for another setup. So the importance of cutting corner in a way in which it does not degrade the functionality of the machine, and also if it does not pose as a risk, is a welcome development.
The overall weight of the equipment will also be less as a result, because fewer materials are used during installations. All these are factors that are taken care of with just one motor.
Now let's look at these schematics we have here. Looking at the power circuit of these schematics here, the power termination of both is similar to a direct online starter. Just that the two power circuit is subjected to change at interval, and at the discretion of the control circuit. That is, only one of the power circuits will be active at a time, not both. And on the other hand, the control circuit comes with an interlock which ensure that only one of the circuits is active at a time, and not both.
I will terminate the power side like these. From the breaker down to the three-phase contactor. From the contactor down to the overload. From the overload down to the motor. With these, when the start button is triggered, the motor will run, and it will continue to rotate. That is when all conditions are met on the control side. However, in order for the motor to rotate in the opposite directions, then there is a need to change the way two of the three cables are terminated to the motor.
The change in the cable terminations will change the order of the magnetic field. And as such, the order of the rotor rotation will be reversed. Again, one of the reasons why only two cables are changed instead of three is because if the three cables were re-terminated in different configurations, the probability that the generated magnetic field will be reversed is less. Hence the reason why only two cables are reversed.
So from the other end of the breakers here, I will terminate it to the contactors in an altered manner. And from the contactors here, it will be terminated back to the overload. With these, we have successfully completed the power terminations.
So, when one of the power circuits is triggered, the motor will be energized. And when the cable's terminations on the other power circuit are interchanged, then the direction of rotation changes. Now, there is a need to devise a perfect control termination for these two power circuits.
There is a need to design a control circuit that will be suitable for these and with an interlocking system. So from L1, I will terminate the following normally close contacts like this. That is from the E-stop to the overload. From the overload to the stop button. From the stop button to the start button. And the other end of the node is terminated to 13 of the normally open contact of K1. And the other end of the start button will be in series with 14 of the normally open contacts of the retaining circuit, while the common point will be terminated to 71 of the normally close contact of the reverse contactor, which is known as K2. and 72 of the normally closed contact will be terminated to A1 of the forward contactor, also known as K1. And the other end, which is A2, will be terminated to neutral.
With these, you have successfully completed the forward terminations, which is interlocktable K2. However, there is a need to complete the reverse circuit.
Yes. So again, from the common node here, it will be terminated to the other circuit here, and from which it will be in common with the one end of the start button, and with 13 of the normally open contact of the retaining circuit, while the other end of the start button will be common to 14 of the normally open contact of the retaining circuit. From the common point of these terminations here, it will be terminated to 71 of the normally closed contact of the forward contactor, while the other end, which is 72, will be terminated to A1 of the reverse circuit, which is also called K2. And A2 will be terminated to neutral.
Electrically, these terminations can be said to have been completed. The terminations will work when the forward start button is triggered and also when the reverse is triggered also. However, it can't be deployed yet for robotics and process utilization that required fast switching in both configurations.
That is because when the motor is purposely put in the reverse direction, at that moment that it is rotating in a forward direction, that will not be acceptable. Which is because there will be a force that tends to cancel out the other newly generated magnetic force. At that moment, there would be an increase in the current drawn by the coils. And as such, the breakers would trip at these points. That is because the current has exceeded the current rating of the breakers. And in the long run, the insulation of the motor will be gradually affected over time. Which is why the lifespan of motors found in robotics or bi-direction conveyors breaks down easily.
One of the ways in which it can be prevented is by using a braking system, which will come on when any of the contactors are not energized. That way, the energy can quickly be dissipated before the next contactor closes. Because in robotics and conveyor systems, directions of motion changes in fast pace.
That is because the switching is done automatically via PLCs. And it is fast pace. So using braking ensures that the inherent energy is dissipated on time.
It is understandable that in a machine that moves items in bi-direction ways, and in less time at intervals, then there is need for a braking system that will be used to dissipate the unwanted energy early enough. However, that will not be enough, which is because the braking contact do wear off over time. So basically having a motion sensing device will act as a failsafe which will ensure that the axial rotation of the rotor is at zero before the next contactor can be energized.
It is important that we have all these things in place. This ensures that the rotor is always at rest at each interval before the next contactor can be energized. This will increase the life span of the electric motor. That is because, at every point in time, the current drawn is always within the rating of the coil. Also, the lifespan of the breakers will be elongated as a result also. So that is it on electric motors in general, and starters with moving parts. I hope you have learned something new today. See you at the next one.